Hi, so I wanted to do a video today, just a brief introduction on integration by parts. I'll show the setup for how it works, and we'll do one quick example, and then I'll do some other videos with some variations, some more complicated examples. So to start with, we have this formula on the board, and we'll show where this comes from. The integration by parts formula is basically comes from the product rule of differentiation. So let's look at that. The product rule says if we have two functions, u and v, and we take the derivative of those, it's going to be just the derivative of the first times the second function plus the first function times the derivative of the second. So like we could do a quick example. Like let's say if we have x sine of x, and we want to take the derivative of that, let's get the derivative of x, which is 1, times just sine of x, plus x times derivative of sine of x cos x. So we end up with this. Now, the integration by parts is just a rearrangement of this. So if we go back to our product rule formula and we get the integral on both sides, we'll end up with uv equals u prime v plus uv prime. Now what we could do is rearrange this a little bit. What we can do is we can subtract this on both sides. And what we'll end up with, then we have the integral of uv prime equals uv minus the integral of u prime v. So that's basically how we come to this formula. Now, I think this can be a little abstract, so I think what we need is an example how we use this. So let's say we have the integral x cosine of x dx. Now, the problem here is we know how to integrate both parts, right? We know how to integrate cos x, we know how to integrate x, or differentiate, but up to this point, if you don't know integration by parts, then you probably don't know how to do this integral right here. So what we do is we have our uv, and what we do is we assign, and actually, let's see, we're going to be using this. So we're going to assign one piece as u and the other piece as v prime. And we tend to do it based on which is easier to differentiate and which is easier to integrate. So let's say, for now, let's just call u equal to x, and we'll call v prime equal to cosine of x. And then doing that, so we also want to have, so in this equation, we need u prime, and v prime. So we'll also get u prime, the derivative of u is going to be just 1 dx. And then over here, to get v, from v prime, we need the integral of v prime. So right, if we get the integral of v prime and the integral of cos x, we'll get back v is just equal to the sine of x, because the integral of cos x is sine x. And we're going to ignore the constant of integration, right? We could include this, but the reason we don't is because in the process it just cancels out and it doesn't matter. So we're just going to ignore that right there. And we're just left with this. So then, coming back to our integral, we can substitute in for uv. We have our u here and we have our v here. So uv is going to be just x sine of x. And then minus, we want u prime v. So that's just going to be 1. We'll take the dx and we'll put it over here at the end. And we'll use our v, which is sine x. Okay, and then all we need to do is integrate this piece right here. Bring this down, so we'll have x sine x minus, integral of sine x is minus cos x, but minus and minus is plus. We'll just do that and a plus c, and we're done. So you can see how that process of integration by parts allowed us to integrate this thing that we didn't know how to integrate before. The tricky part is, I think the hard part for people is to figure out what part is going, when you have to choose, what part is going to be u and what part is going to be v prime. And what you want to do, like the first thing I like to try, like the easiest way to look at it is you're going to need to differentiate the u and you're going to need to integrate the v prime. So you need to choose, when you choose v prime, the first thing to look at is to choose v prime, you need to choose something that you can integrate. And then for d, you want to choose something you can differentiate, but you can pretty much differentiate almost anything. So that's why choosing the integral part is usually more important. And the only thing to consider though with one thing with the part with, even though everything you can differentiate, it's nice if the part you're differentiating is a constant or a polynomial, because you know that a polynomial will always get simpler because you're reducing well, not always, but generally a polynomial is going to get simpler and it's going to reduce the powers when you differentiate, so you're getting closer to an answer. So you can also consider that when you differentiate. But anyway, that's just the introduction right now, so I'm going to leave it there, and then in the next video we'll do some other examples.